ABC, circle of functions, unit circle. We might spend a bit of time on this because this is your most essential skill. If you don't get this, then there's no point doing anything else afterwards. So sketching, solving, you can't do all that unless you understand the unit circle or finding the symmetry properties. So that's what I'm going to spend today doing, and I've got some quizzes just so that you can practice making sure. Oh, I know, jeez, God. Why am I wanting the best for you? I know. Here we go. Let's start off with degrees and radians. Let's think about what it means when you say cos of an angle or sine of an angle. So when you look at it, what I want you to do is to understand what's happening overall. Because once you understand what's happening overall, the graph and everything else is easy. Finding out solutions is easy too. Okay? So we'll start off with what we call a unit circle. Everything comes out from a unit circle. Now when we say unit, what does unit mean again? Richie? One. Okay, so when we say unit circle, what we're really saying is that you've got a radius of 1 unit. Hence why it's called a unit circle. Unit 1, 1, 1, 1, 1, and it's a length of 1 all around. So, if I ask you to find the circumference of a circle, okay, what's the formula for the circumference of a circle again? Yes, Ben? 2 pi r. Yeah, 2 pi r. So in this case here, in a unit circle, the circumference would be 2 pi, which is the perimeter of the circle, and the length, how long is it? And we go pi times d, or 2 pi r, and the radius is 1. So that's why you would say 2 pi times 1 is just 2 pi. Which conveniently, we're saying here that when we're finding the circumference or distance around the circle in 1 revolution, you're saying that you're going 2 pi distance. That's what you're saying. So if I draw it on the screen so you can see, I'm just saying that if you started here and you went all the way around the circle, that's a distance of 2 pi. Okay, so you have to understand that 2 pi is a number. That is a number. It's 3 point something times 2, so 6 point something. Yeah? That's a distance. And it could be in centimeters, it could be in meters, whatever it is. We just know it's 6 point something around 1 circle if you have a radius of 1. Okay? So when you write pi and 2 pi and 3 pi and like half pi, you're really just talking about the distance around the circle. And that's what circular function is all about. When you say find sine of 30 degrees, you're actually just saying how far it is or how far they've gone. Now, notice on the side here, I wrote 360 degrees equals 2 pi, because not only are you going around the circle, we also know that as you're going around the circle, it's also determined by the angle that you make. Now, if you go full circle, it makes sense that it's 360 degrees. So we're going back to the question of what does it mean when you learnt in year 11 where it was like sine of 30 degrees. See, 30 degrees would be something like this. Starting at the 0 degrees part, 30 could be something like this. That's 30 degrees. So this is where the distance that we've covered. Okay, so we're just saying, all right, around the unit circle, this is the distance we've covered. And now remember your trigonometric functions, you've got sine, cos, and tan. All they've done is they've separated it into different parts to describe this distance. Okay, that's all it is. When you're doing sine of 30 degrees, which, just out of curiosity, anyone remember what sine of 30 degrees is? Okay. No, 30 degrees is pi on 6, or what is sine of 30 degrees? Half. Okay, the answer is equal to half, and what you're really saying there is there's some sort of distance that equals half. Now in this case here, what I've actually learnt is that we said a distance. So unit circle has a distance of radius 1. When you say sine, and we know that sine 30 degrees equals half, in this case here, the half actually represents the y values. That's what sine is. Now the question is, well, why is that? Why is sine the vertical distance? So at this point here on the unit circle, this is where the point is. From that point down, vertically down to the x-axis, from here down, that's equivalent to a half. So the question is, why is it the vertical distance? Why is it at from this very point here, we said 30 degrees, it comes all the way down. Why is this equal to half? And that's the question. Now, remember, sine, cos, tan has ratios. And when you learnt in year 9 at Sakatoa, So sine is the ratio of what again? Richie? Over hypotenuse. Opposite over hypotenuse. So I'm going to do this. You said sine of the angle is opposite over hypotenuse. Opposite, which is this length here, this y distance, over the hypotenuse, which is actually the radius from the center to the end of the circle. The radius we know is 1. So it makes sense that you're really just saying it's O over 1, which is the opposite. But the opposite is just the vertical distance. That's why when you say sine of 30 degrees, you're just saying y divided by 1. Whatever y is, which is the y values, the height, sine of 30 degrees equals to half. Half is your y value. That's why sine represents the y values. Whereas cos, on the other hand, cos is your adjacent. That's your x values. X divided by 1 will give you this distance here. So we're just saying cos of an angle will tell you the x value at that particular point. So if I just rub everything off and I just get you to understand what you're actually doing, we're just saying that when you make 30 degrees and you land here, that's an xy coordinate. At that xy coordinate, you can rewrite it as this is the y value and this is your x value. You can break it up in 2 parts. At that point there, we're just saying this x value is equivalent to cos of the angle, and this y value is equivalent to sine of the angle. Okay, that's all it is. Out of curiosity, anyone know what the tan is then? So we got sine of an angle, we've got cos of an angle. What's tan representing? The gradient. So you don't have to memorize that because you learnt that in chapter 9 when we're talking about calculus. Tan theta was equal to, sine of theta over cos of theta. But we just figured out that sine of theta was y and cos of theta is just x. Y divided by x is just like vertical divided by x tells you the gradient. So when you say tan of theta, you're really just talking about the gradient. So that's what I'm saying, that at every point on the circle, you can split it up into 3 different parts. That's why you have 3 different trigonometric ratios. You have either just the horizontal length, you either have the vertical length, or you have the gradient. That's why you have 3 parts. Okay, so tan is the gradient. That's what tan represents. You got your cos of the angle, tan of the angle, and sine of the angle. That's all they are. And when you're sketching the graphs, that's all you're really doing. You're sketching a graph of, let's just have a look at what happens with x as I move around the circle. So you can see x starts at a maximum distance of 1, but as you move around the circle, the distance of x gets smaller and then it goes onto this side and comes back. And that's all the cos graph is describing. So if I actually draw the cos graph on the slide here for you to see, cos graph, this is the cos graph. Okay, and it starts at 1, minimum 1, 2 pi. You see, if you look at that graph there, it makes sense what I'm describing. I'm just describing the unit circle. Starting at maximum 1, so I start at maximum 1. But as I move around the circle, see if I get to 30 degrees, x value is getting smaller. By the time I get to the vertical point, which is at 90 degrees, I should have x equals 0. That's what's showing here. See, x equals 0, and that has to be 90 degrees. By the time you move from 90 degrees, as you move around the circle at this point of that angle, x is getting larger, but in the negative direction. Up until you get to pi, 180 degrees, it makes sense that x is now its maximum length in the negative direction. That's why at pi, you reach a maximum length of -1. And it goes back to 0 because you get to 3 pi and 2. And then, well, not 3 pi and 2, 270 degrees. And then by the time you get to 360 again, it's full length of 1, which is why 2 pi goes back to maximum length of 1. That's what I'm saying. You see, everything comes from this one unit circle. You got your cos, you can do the same thing for sine. See, sine starts at 0 because it's the y values. Y value starts at 0 and it keeps increasing as I move the unit circle up. You can see it reaches a maximum of 1. That's why sine starts at 0, reaches 1 at pi and 2. Okay? So, and then if you really think about your tan graph, why does a tan graph look the way it is? See, I'll draw a tan graph and you can see you're doing all these exercises based on the unit circle. See, if I drew a tan graph Why does it go on to infinity and you got pi on 2 is the asymptote and negative pi on 2? Because same thing again. If I'm moving around the circle, we're just talking tan is the gradient. Tan's positive, it's getting larger and larger, the gradient's getting steeper and steeper and steeper up until it gets to 90 degrees. It's a vertical line. And we know a vertical line has what kind of gradient? It's undefined. Which is why 90 degrees, which is pi on 2, pi on 2 distance, that's the distance, pi on 2, it's undefined at pi on 2. And it's the same thing when you go the negative direction, it's undefined at negative degrees, negative 90 degrees. And that's technically what I just described in one unit circle. I've described like 4, 5, 6 exercises already. Okay, you're just doing how to change degrees to radians, which I'll show you from that little box over there. You're learning how to find out the exact values. So doing like tan of 30 degrees or tan of pi and 6, so exact values. Then you're going to learn about sketching graphs. Sine, cos, tan graphs. You get exercise variation, that's 5 exercises already. And then what's the last thing before you sketch? You have to know how to find x-intercepts. How do you find x-intercepts? It's just knowing, if sine of x equals half, when does it equal half? You're really just saying when will I have a y value of half? And it just keeps going and going. Okay, but that summarizes chapter 6. Technically, if you understood everything I just said there, you can slowly work through it and knock it all down. But it all comes from a unit circle. Okay? But for today, my aim is to slowly bring you into the skills. We're just going to talk about this property. And then we're also going to talk about memorizing the exact values, which I think I did when we did a hand method. When did we do that again? That was in matrices, I think. Can't remember when I taught it. But I'll teach that again and then make sure that you guys can find exact values. So 6b is the main part. And then I'll keep reiterating this unit circle because everything goes back to the unit circle. The better you understand the unit circle, the better it is to do chapter 6. Okay? All right, here we go. So let's think about this. 360 degrees equals 2 pi. The first exercise, not 16a, 6a. The first exercise is actually just about you converting, how to convert radians, which is the distance around the circle. Remember, 2 pi was the distance, not the angle. Okay, how do you convert, let's say, 45 degrees to radians? Okay, meaning I want distance. Okay, so what I'm really saying is in a unit circle, when you say an angle is 66 degrees, I guess I want to know what the equivalent distance is. That's what I'm talking about when we say radians. Radians is just the distance around the circle. Angle is just where you're at. Okay, so 66 degrees. How do we change that? So you don't have to memorize any rules. In exercise 6a, they give you rules, but I don't want you to memorize it because the easiest way to understand is this property here. 2 pi r, radius unit circle has only a radius of 1, so that's why you know 2 pi r, which is the circumference, is 2 pi. But full circle makes 360 degrees. Now from here, you can work out for 1 degrees, how much is it in terms of radians? Now, how do you change 360 back to 1 in terms of ratios? What do I do? I would add, subtract, divide, multiply. What do I do? Divided by. It makes sense that to get 360 to 1, I would say divide 360 on the left. But then that means I have to divide the right-hand side by 360 as well. Now, if I do that, 2 pi on 360 can be simplified down to pi on 180. That's equivalent to 1 degrees. So if I now want to know what the radians is, okay, so let's say if I asked you 66 degrees, which is the question I asked just then, I said if you made 66 degrees and I want to know what the equivalent distance is, so that's the question mark, you can use this rule here, which really, it's not a rule, it's just ratios. Well, it makes sense. If you know that's 1 degrees, to get to 66, you need 66 of these. So 66 of these pi on 180s tell you what the radians is, because that's for 1 degrees. So you would say, oh yeah, that would be pi on 180 degrees times 66 of them, because to get here, you'd have to times 66, and from here to here, you have to times 66. And whatever that simplifies to, that's your radians. 66 over 180, simplify that down, that's the distance on the outside of the circle at 66 degrees. But that's the one formula that you're doing, the first exercise. What's the other formula? Same thing. What if you want to convert radians to degrees? So if I had same property, let's stick with 360 equals to 2 pi. Well, instead of finding 1 degree, how about we find 1 radian? What's 1 radian equivalent to in terms of degrees? It's the same thing. If I want 1 radian, which we use a little c on top to represent radian, how do I move from 2 pi down to 1? What would I have to do? What is it? Yeah, divide both sides by 2 pi. So here we go. Dividing both sides by 2 pi, divide by 2 pi, and you get 360 over 2 pi, which reduces down to 180 on pi. And that's your second rule. Which again, like I said, you don't have to memorize that. You can figure all that out. See, that's just saying for every 1 radian, so distance around the circle, this is how many degrees it is. 180 divided by pi. So if you wanted to change, let's say, pi on 4, you wanted to know what the angle was in degrees. Well, to get from 1 radian to pi on 4, you'd have to times it by pi on 4. You need pi on 4 of these radians. So that means you need pi on 4 of these 180 over pi's. So you think about it, pi on 4 multiplied to 180 on pi, it nicely cancels out the pi's. 180 on 4, which, what is that? 4 into 18, 4 times 45. There you go. 45 degrees. Okay? So that's all you're doing. So you're given these two formulas in your exercise book or in your textbook, but you don't need these two because they make sense. They're just working on ratios. 360 equals 2 pi. That's it. Okay, so that's the first exercise, learning how to convert degrees to radians. And the other one is converting radians to degrees, but I'm using the same technique for every one of them. Okay, it's just ratios. How do we feel with that? Does that make sense? Yeah? All comes back to the unit circle. Unit radius 1. That's how you know it's 2 pi. Okay? I'm just going to give some time for you guys to copy. In the meantime, we have now Mazen. Let's see, Verity. We also came Aaron. Yeah, that's about it. All right. Now, let's go to ink slide. Okay. Oh, do you want to see that again?
Yeah, I do.
All right, cool.
Whoa!
I know. Ugh.
Oh, wait, one more time.
All right. Ugh.
Oh, yeah.
I know. Now I have to do it for the last time. There you go.
Yeah.
Okay. Now these are called exact values. You are required to memorize these, especially for exam 1. They're not going to give you exact values. It's like your times tables. You're expected to do your times tables. At this point, you're expected to know your exact values. Yeah? Now, there's a total of 5 special angles, 0, 30, 45, 60, and 90. There's a total of 3 functions, sine, cos, and tan. So for every function, you have 5 different angles. So technically, there's 15 exact values there. 3 by 5 gives you 15, right? Technique I showed you at the start of the year on how to memorize them all because you have to know them. Okay, you can learn it any other method the way you like it. I'm just teaching you the way I normally teach it. Okay, for you to memorize all 15 are these. That is my hand. Back in the days when I used to lift, I had calluses on them. But here we go. We got 5 fingers for the 5 special angles you have. 0, 30, 45, 60, 90. On my thumb area, it doesn't have to be your left hand or right hand, it's just that as long as you go from left to right. Yeah? 0 degrees, pi and 6, pi and 4, pi and 3, pi and 2 represent 0, 30, 45, 60, 90. Okay, so that's what they all represent. Pi and 6 is your 30 degrees, pi and 4, which is your 45, pi and 3, 60, and pi and 2, 90. A way to sort of remember it is the larger the value in the denominator, the smaller the angle is. Okay, because it makes sense. If you're dividing by a large number on the bottom, it makes it smaller. So if you're dividing by pi and 2, that makes it larger. Okay, the largest angle that you have is 90 degrees. So I've got my 5 angles. Now, on my left and on my right, I've written sine and cos. Okay, sine will always be on the left, cos will always be on the right. In the middle is what you need to remember. So that's the only one thing you're going to remember. Then you can use that formula for only sine and cos. This will help you get 2/3 of what you need to know. So 10 out of 15. Okay? So root of something divided by 2 is the formula. Now, how does it work? This formula will work like this. If I want to find, let's say, sine of 30 degrees, what I'm going to do is I'm going to drop down the finger that represents 30 degrees. In this case here, in the picture, that's my 30 degrees, that's my index finger, so I'm going to drop that one down. When I drop that down, remember sine represents the number of fingers on the left-hand side of this finger that's dropped down. Okay, so the number of fingers I have on the left-hand side is 1. I only have 1. I have the thumb. Okay, so because I only have 1 thumb left over on the left-hand side, I would now say the formula is square root of 1 over 2. In this case here, root of 1 we know is 1, so the answer is half, which makes sense. I do have it. Sine of 30 does equal to half. If I were to do another way, let's say I do cos of, let's do cos of 45 degrees. Okay? So same drill. 45 degrees, you got to figure out which finger represents my 45 degrees. And in this case, it would be pi on 4. Middle finger comes down. So I drop my middle finger down. Okay. Question is, how many fingers do I have on the right-hand side? Because it's cos. Cos is on the right-hand side. So the number of fingers I have on the cos side, I have 2. There's only 2 fingers here. There's 2 of them left over here. Okay, so there's 1 and there's 2. So I'd say the formula, putting it in, is square root of the number of fingers I have for the cos side, 2, divided by 2. Okay, now root 2 on 2 is the same as cos of 45, which is 1 on root 2. They're both the same. 1 on root 2 and root 2 on 2, it's just that this is a rationalized denominator. Okay, so if you times top and bottom by root 2, you get root 2 on 2. Okay, so cos of 45 degrees right there will give you root 2 on 2, and that means technically if you just follow that technique, you would remember all 10. Okay, so if I did cos of 90 degrees, so you drop down the 90 degree finger, cos of that, cos means the number of fingers I have on the right hand side, but you can see cos of 90, if I drop this finger down, I don't have any other fingers, unless you have 6 fingers, but in that case I'll tell you, forget about the other 6 finger. And you have no fingers on the right hand side, so therefore it's 0, square root of 0 divided by 2, 0 divided by 2, 0. That's why cos of 90 is 0. Okay? And that's the same thing with sine of 0. Sine of 0 would mean drop the thumb. There are no fingers on the left hand side, so 0 divided by 2 again. And that's why sine of 0 is 0. Okay, so that allows you to find out all 10. How's that feel? It's alright? Because I'm going to test you guys later. Yeah? Alright. Now, that gives you the first 10. So how do you memorize the next 5? Now, if you happen to forget this, you got my video, or on YouTube, I've seen some of these techniques, but the one that I haven't seen is this one. This is my one. Okay? So for tan, this is my formula. Tan, same thing. You still have your 0, pi 6, pi 4, pi 3, pi 2. The only difference is the formula that's changed. Okay, so this is the formula that I made up. And so all it is, because I knew tan was sine over cos. So yeah, I know, I felt really proud about it. I was like, yeah, this one works. So here we go. In order to do this, the difference is the formulas here. We're just simply saying, if I wanted to find tan of, let's say, 30 degrees, then you still drop down your 30 degree finger. Okay? Now tan is equivalent to the number of fingers for sine, because it's sine over cos. Number of sine fingers, we have 1. 1 on the left. And then how many fingers do I have for cos? I've got 3. So it's 1 out of 3. But then whatever that answer is, whatever that ratio is, square root them all. Now what you can see is square root of the 1, square root of 1, which is 1, and square root of 3, I don't know. So the answer is just 1 on root 3, which is correct. You can do the same thing. Let's do tan of 60 degrees. It's tan of 60 degrees. We start again. 60 degrees is your ring finger. Drop down the ring finger. How many fingers do I have for sine? I've got 3. 1, 2, 3. So 3 fingers for sine. How many fingers do I have for cos? 1. So it's 3 out of 1. Which is the same thing as 3. But remember, square root that answer. Root 3. And that's correct as well. It's tan of 60 degrees is root 3. Okay? How do you feel with that? That's pretty alright. So only 2 formulas there that you need to remember. The angles you'll remember because of your 5 fingers. So there's 5 special angles there. And that will help you remember 15 or all 15 exact values. But you must remember them. Okay? Good? Copy the formulas because I'm going to test you guys. Okay? Every one of you is going to get one. Yeah. So think about it. Got it? 5, 4, 3, 2, 1. Alright, I'm taking it away. Goodbye. Alright, here we go. And once we run out of those, I'm going to ask you my own individual ones. Okay, here we go. Sine of 30 degrees, what is that equal to? Can I please have Monica? Half is correct. We do have half. Again, sine 30 degrees is your index finger. Drop it down. Number of sine fingers, 1. Formula was square root of 1 divided by 2. Yeah, so that's why it's half. Next one. Tan of 45 degrees. Can I please have Trent?
It is
1. Correct. Again, number of sine fingers. Drop down the middle finger. So you got 2. Out of cos fingers, 2. And square root that. So that gives you a root of 1, which is 1. Cos of pi and 6. Which one's my pi and 6? Anna, cos of pi and 6. It is 3 on 2. Same thing again. Drop down your index finger. Number of cos fingers. I've got 3. Square root that. Add a 2. That's my formula. Which is root 3 on 2. Okay. Next one. Tan 30 degrees. What is tan of 30 degrees? Can I please have Richie?
1 on root 3.
It is 1 on root 3. Correct. Tan of 30 degrees. 30 degrees your index. Drop it down. Number of sine fingers I have, 1. Number of cos fingers I have, 3. Square root that. That gives you 1 on root 3. Okay? Next one. Sine of pi and 2. Shirley. It is 1. So again, same thing. Drop down the 90 degree finger with your pinky. You've got 4 of these sine fingers. Root it and divide it by 2. That's the formula. That's 2 on 2, which is 1. Next one, cos of pi and 4, Ian. Root 2 over 2. So same thing again, or you can have 1 on root 2, up to you. Pi and 4 is your middle finger, drop it down. Cos is the number of fingers on your right. So you got 2, square root that, and then divide it by 2. That's how root 2 and 2 comes from. Yeah? Last one, tan of pi and 2, Verity?
Not defined.
Undefined, good. Undefined, same thing again. If you look at the pinky, drop down the pinky. Number of sine fingers, you got 4. Divided by number of cos fingers is 0. And we know that 4 on 0 is undefined. Okay? Now, for the rest, let's test you guys now. So, those are the ones I had. Put them I chose. Let's go. Athena. What is sine of 60 degrees? Root 3 on 2 is correct. Alessia, what is tan of 60 degrees? Root 3 is correct. Aaron, what is cos of pi and 6? Root 3 on 2. Mazen, what is tan of pi and 6? 1 over root 3 is correct. Daja, what is sine of 0? 0 is correct. Let's go with Michael. What is tan of 0? It is 0. I've chosen everyone on that side there. Let's go Liffy. What is sine of pi on 4? 2 on 2. Fantastic. Rose, what is 10 of pi on 4? 1, good. 2 on 2 is 1, and then root of that is 1. Okay? I think I've gone through. Jun, what is cos of 90 degrees? No, that's cos of 45 degrees. 90 degrees from here to here. 0 is correct. Ben? No, I haven't Ben. What is?
No.
Give a real hard one.
Yeah, I'm giving it a hard one.
I'll make it.
What's sine of 3 pi 4? That's today's session.
Yeah, that's right.
Say it again. Well, how do you get it right? I was checking if it's a negative or not. Yes, you're right. Yes. It would have been a negative. Yeah. All right, good. Excellent. All right, here we go. Now that you've learnt your exact values, that was 6B, by the way. 6B is knowing your exact values. 6A was knowing how to convert. Now, 6B and C, you need to know how to do what I just did with Ben, where I said sine of 3 pi and 4. So, on this little quiz I have here is to practice that, because that's the key part. If you can't do this, you can't solve. Without being able to do sine of 3 pi on 4, or doing like, let's say cos of, 11 pi on 3, okay, without figuring out what all those is, because you learnt the exact values, now you have to use those exact values to figure out angles that you haven't seen before. So 3 pi and 4 is more than your 0 to 90 degrees, but it's still the same angles. Okay, so that's what we're going to work on today. I'm going to make sure you understand what it is when you say cos of 11 pi and 3. Okay, what does it mean? Now this is what I want you to see. This is what you've learnt so far. You've learnt that if I had 30 degrees, which is the same thing as saying pi on 6, okay? Pi on 6 is 30 degrees. We learnt that at this point it has an x and a y coordinate. We learnt that at this point you have an x length, so from here to here is x, and you also have a y length, which is this point. Okay, so how much is y and how much is x? You learned to find x by doing cos. So cos of 30 degrees will tell you how far horizontally it is. What's cos of 30 degrees again? What's cos of 30? Say it again. Root 3 on 2. That is correct. So we know this is root 3 on 2. Y is the sine of 30 degrees. What's sine of 30 degrees? 1/2, okay? So we just know now that the coordinates at 30 degrees, it's root 3 on 2 and half. That's what we know, okay? Now the cool thing is, this is called symmetry properties. If you know this is 30 degrees from here to here, if I drew it by symmetry, because it's a unit circle, circles are symmetrical. That means if I drew the same angle on this side and I said this was 30 degrees, from here to here is 30 degrees, you can expect that the length and height has to be the same, true? Because it's the same angle, it's the same triangle. So that means this has to still be half, and this has to be still root 3 on 2. But on your x-axis, or on your Cartesian plane, there is a difference between this direction and that direction. Now this is root 3 on 2 in the positive direction. This would have to be root 3 on 2 in the negative. So this is negative root 3 on 2. But this is your y values that are in the positive direction. So both of these are positive halves. So what you can say is at that coordinate, this would be negative root 3 on 2, but it's still half. True? Then if you think about that logic, well then you can draw another triangle and you can say, well, what if I'm at this point on the circle where you have an xy coordinate again, but it's also 30 degrees. So if it's 30 degrees, what we can say is that the length has to still be the same, And the height still has to be the same because it's the same triangle, the same angle, 30 degrees. So now you know that this coordinate, both it is negative root 3 on 2 and it's also negative half. Does that make sense in what I'm doing? Yeah? Now this is a cool thing, and I'll show you why. I'm going to delete everything so that you can sort of see why. You know, back in year 11 or maybe previously if you've learnt it from other teachers, they normally call this your ASTC. Do you remember that? See, what I don't like is students memorizing that, and the problem with that is if you've done a lot of practice, then you'll memorize how to do it, but you don't get what's going on. So when it becomes theoretical or abstract, you can't answer the question. So with this one, question is, why is it A, S, T, and C? You just told me here we had X, Y, both of them were positive. Both X and Y coordinates were positive, true? At 30 degrees. On this side here, you told me that it was X was negative, but Y was still positive. Now remember, X represents your cos, Y represents your sine, and T, which is your tan, which is the gradient. Now if you think about it, if X is positive, Y is positive, tan is really just sine divided by cos, which is positive over positive. Well, you can see all of them are positive. Cos is positive, sine is positive, tan is also positive. You got positive divided by positive. If you think about your S, what they're saying is everything in this region, sine is positive. Why is that true? Well, if you think about it, C, which is your X values, it's negative. Sine is clearly positive because that's your positive Y values here. But then you think about tan, well, tan is the gradient. Gradient is sine divided by cos, positive divided by negative. Makes sense. And positive divided by negative, you get negative. And that's a negative gradient. It makes sense. Tan's negative, so the only thing that's positive there is sine. But you didn't have to memorize that because it's just there. You can see that. You guys told me the coordinates without thinking much. You didn't have to memorize ASTC. It makes sense that tan is positive here because both of the X and Y are negatives. So tan has to be positive. Two negatives, if you divide them, it gets you positive. So it makes sense that's his tan. Why is cos only positive? Same thing. Sine is negative. Cos is positive. Tan has to be negative. There you go, ASTC. No need to memorize. That's better. I had all student teachers crap. Alright, well, that's one I was taught when I was in high school. And that's what I'm saying, like, I'd rather understand it rather than memorizing all that, and that's how I was taught, all student teachers crap. Yeah. Anyway, here we go. Let's move on to, so now.
Whoa.
Oh, did you want to see that?
Why does this one have animations but the previous ones don't?
I used to do this for Evis, and I had sounds and sound. I turned off the sound, by the way, so there's probably a lot of sounds going on there. And what happened was I felt like over time, I was doing these quizzes with them, but just in class. I called out because I had 60-something kids in that class, and I couldn't do a quiz. I can't check them all. So I called them out, and I'm telling you, at that point, I taught them a lot, and I said, what is sine of pi on 6? And they sat there, and I'm like, I don't know, sir. And I'm like, I was like, Jordan, what is this? And he couldn't answer. I'd be like, David, what is this? And he couldn't answer. And I was like, you guys are terrible. So I just felt like they were all into this whole music and this entertainment. And there's a difference between being a teacher as an entertainer or an educator. And I felt that I was becoming more of an entertainer, where I had all this music going on, all the slides, but students aren't learning. So to me, I keep it simple. If you notice, every PowerPoint I do is just white in the background, and it's just red, blue, and black. Keep it simple. I try not to overcrowd the slides so your eyes don't go left and right. It's just there. I just keep it as simple as it is so you can take the information. Whether you write it down or not, it doesn't matter. It's just whether you understand it. But I've learnt from my mistakes that entertaining kids is very different from educating them. That's why I take off the music and I don't do animations anymore.
Can we do music for ability?
No.
Oh, why not?
No, absolutely not. Just even today's session, that was the first time I had the scrunch, How many of you are like, oh, do it again, do it again? But does it add any value to your education? No, it doesn't.
I will remember the slide.
What was on that slide? Do you remember that it scrunched? What slide was that?
Unitcircle.
Is it the units? I don't even know.
I guess we'll have to go back and watch the animation again. To see.
Yes. Is it the units? Oh, you lied. You didn't remember, did you? It was the radians to degrees. Yeah, there you go. Now you remember, right? But it proves my point.
Wait, remember.
All right. Now, here's the skill that I want you to be able to do. So we said, we know now that the symmetry properties means that if you know the angle's 30 degrees, that means you can figure out for every other angle. So when you say sine of 30 degrees, you told me that was half. Now if I draw it, this is 30 degrees. Sine represents the height. So you now know the height is half. So that means from here to there, that point has a y value of half. Now if I draw the same triangle and I said this was 30 degrees, okay, you know that this point here has to have the same, oops, it should be more like over here. There we go. You know that the y value at this point has to be half as well. But the angle, when you say sine 30 degrees, see, we're starting from here, that's 0 degrees, up to here is 30, that's true. But then if I move the cursor around on a protractor, what's the angle from here to here? How would I work that out? Not divide, take away. 180 take away 30 will tell you this is 150 degrees. True? So that means sine of 150 degrees should also equal to half. Now if you think about it, these 2 points will always equal to half. The question is, what's the angle each time? Now this is 360 degrees if I go full circle. And if I moved up a bit by an extra 30, 360 plus another 30 will give me sine of 390 degrees should also equal to half. True? And then if I think about it, this is 360. If I add another 180, what would this be now? $540. Okay, so this is 540 degrees, but then that means if I went around, that's 360, 540. But what if I only want to go from, this is 360 and I want to stop right there? Yeah, 360 plus 150 or 540 take away 30, which makes it 510. So sine of 510 degrees is equal to half. Now what I just demonstrated to you right there is, this is called symmetry properties, but also one more thing. What was difficult? It wasn't that you didn't know it was half. What was difficult? Big numbers. Big numbers. So I only did just 1.5 revolutions there. And that was already difficult to work with the numbers. But the reasons why we work with radians more, if you look about circular functions, everything's in radians. Why? And I'll show you why. Because it's much easier to work with. If you think about 30 degrees was pi and 6. True? Pi is over here. Now the nice thing is, because in a unit circle, when you're moving it around, they're in integers. So from here you start at 0, you go all the way here, that's pi. I go the way here, that's 2 pi. Ever go all the way back here, that's
3 pi.
Okay, now you worked that out much faster than you did instead of working, what, 360 plus 180. True? And then 3 pi, if I said another one, that would be?
4 pi.
4 pi. Now what you notice is all the even pi's are on the right hand side and all the odd pi's are on the left hand. This is 5 pi. Now that's nice because it means that when I give you radians now, if I said 77 pi, where would that be at? On the left. But if I said now, what's 1,250 degrees? Where am I at? Somewhere, but it's hard. What I'm trying to say is, radians is much easier to figure out where you are in the unit circle than it is working with degrees. So now the nice thing is, you said this was pi and 6. Well then to find out this angle here, it was pi losing 5 on 6. So you would say sine of pi minus pi and 6 should equal to half. But what's pi minus pi and 6? What's 1 whole removing 1/6? 5 and 6. Which means Now you know how to find sine of 5 pi and 6. You see now, with the questions I asked before, I asked Ben sine, oh, I'll write it down here, sine of 3 pi on 4, which is 3/4. 3/4 hasn't made one whole yet. So if you think about the unit circle, where's 3/4 of a pi? See, this is pi. 3/4 means that with 1 pi I've lost a quarter. That's why it was easy to figure out what sine of 3 pi and 4 is. See, sine of 3 pi and 4, if I just fix the circle right now, if I just fix all, I'll delete all of this. Sine of 3 pi and 4, you know that 3/4 is not even 1 pi yet, so this is 1 pi. You know that you're losing a quarter because 1 take away quarter will make 3 pi and 4. So that means this is 3 pi and 4 here. And if I asked for sine is just the height. Now this one we know because that's a quarter, pi and 4. And you've learnt from your exact value sine of pi and 4. So what's sine of pi and 4? Root 2 and 2 because you're doing this finger. This is pi and 4, drop it down. 2 for the sine fingers, root of 2 on 2. That's why it's easier to do. Okay? And that's why when I ask you these kind of angles, when I say that sine of 3 pi and 4 is the same thing as saying sine of pi minus pi and 4, which is the same thing as sine of pi and 4, which we know is root 2 on 2. And that's the key. That's the skill that you want to be able to take, because without this, you can't solve for circular functions. Okay, you need that skill. That's the bread and butter of chapter 6. Okay, kind of like chapter 9, understanding gradients is a derivative. Chapter 6, the bread and butter is the unit circle with symmetry properties. That's what I'm trying to describe. Okay, so we know that sine of pi and 4, and we can see that the y values here are positive. That's why it's positive root 2 and 2. Whereas Ben said before, if it was cos of 3 pi on 2, see, cos of 3 pi and 2, I mean pi and 4, sorry. Cos is the length. Cos is the x length. And in this case here, cos of pi and 4, which is root 2 on 2. So we know this distance is still root 2 on 2, but be careful, you're in this region now. And in this region, we can see that that's a negative x value. So that's why cos of 3 pi and 4 is equal to negative root 2 on 2. Does that make sense? Okay, yeah. So it takes a bit of time to work on that, but eventually I want you to be able to do it in your head. So if I asked you, tan of 23 pi on 2, you'd be able to figure out where it is in the unit. Because that's the key. The first step is you have to visualize where it is in the unit circle. Then you can work it out. Okay, back in year 11, you learned quadrants, ASTC. I don't want you to memorize the ASTC. I just want you to remember where you are in the unit circle. It makes sense. Is the y value negative? Is the x value negative? Those are the only things you got to ask. So if it's tan, you just ask, is it, is the gradient negative, is the gradient positive? I don't want you to memorize it to ASTC. It takes too long. Okay? How do we feel with that? Is that all right? Cool? Because I'm going to get you now. I'm going to get you to think about these. And I want you to work out just the question 1. If you can do the others, great. Otherwise, I just want question 1. There's, 9 of them. There's 9 of them to work with. And it's the same unit circle. Learn the exact values, so use the notes that you've taken. I want you to do the first 9. The first 9 for me. And so that's what we're going to do. So in tomorrow's session, Friday's session, every time you come in, I'm going to start working the exact values. So I might just call out your name, and I'll say, what is tan of 5 pi and 6, and you have to be able to figure it out. Are we going to throw a party at the end? No? Why?
Throw a party?
Don't you already have a party?
Wait.
Class? Wait, what am I celebrating?
Us leaving.
That's a good idea.
The strongest cohort.
Could be it. Yay! Have potential. I thought I'd be celebrating already. Just like as soon as the bell goes in that last session, I'm like, yes! Get out! I don't know you anymore. In fact, that was just recorded.